In recent months, a truly unique situation has begun to develop around one of Tesla's most ambitious projects. While the attention of millions of people around the world is focused on the development of artificial intelligence, Optimus robots, and Elon Musk's new projects, behind the scenes, a technology is rapidly approaching launch that could change the daily lives of billions of people even more than electric vehicles did. We are talking about Tesla's fully autonomous robotaxi transportation service, which in recent years has been considered one of the company's most anticipated and at the same time most controversial projects. After many years of development, testing, and endless debates between Tesla supporters and critics, new details have finally begun to emerge about how close the company has come to the commercial launch of its autonomous transportation system. According to Elon Musk, the project is in the final stages of preparation, which means that the first full-scale deployments of the service could begin very soon. And although many analysts considered such statements overly optimistic several years ago, the situation today looks completely different. Several major publications, including Bloomberg, Reuters, The Wall Street Journal, and Financial Times, have recently been paying special attention to Tesla's autonomous driving efforts. The reason is simple. If the company really manages to launch a fully autonomous transportation service without a human driver, the consequences for the global economy could be comparable to the emergence of smartphones or the internet. Essentially, Tesla is trying to solve a problem that the largest technology companies on the planet have been working on. For many years, hundreds of billions of dollars have been invested into the development of autonomous vehicles. The world's largest corporations have been working on similar technologies. However, Tesla today appears to be one of the leading candidates for bringing autonomous transportation into mass adoption. The main idea behind the project seems remarkably simple. Imagine a city of the future where people no longer need to own their own cars. Instead, they simply open an app, press one button, and within minutes a fully autonomous vehicle arrives. There is no driver inside the car. There is no need to pay for parking. There is no need to worry about insurance, maintenance, or repairs. Artificial intelligence independently delivers the passenger to the desired destination. But behind this simple concept lies one of the most complex engineering challenges in human history. According to information that has repeatedly appeared in Tesla statements and analytical reports, the foundation of Robotaxi is a new version of the full self-driving system. This software platform is considered the company's main asset in the race for autonomous transportation. Unlike many competitors, Tesla is relying primarily on cameras and neural networks, bringing the vehicle's perception system as close as possible to the way humans perceive the surrounding world. Many experts consider this approach risky. Others, on the contrary, believe it is the only possible way to scale the technology to millions of vehicles. According to Tesla supporters, the use of expensive LiDARs and complex additional equipment makes mass adoption too costly. Tesla, however, aims to create a system that can be installed on literally millions of cars around the world. Today, particular attention is being paid to the design of the future robotaxi. Although the final specifications remain the subject of discussion, numerous insider leaks and concepts suggest that the vehicle will be significantly different from traditional cars. The main priority will be maximum transportation efficiency. This means optimizing interior space, reducing production costs, and minimizing operating expenses. According to analysts at Morgan Stanley, the cost of a single ride will become Tesla's main weapon in future competitive battles. If traditional taxis require paying for a driver's labor, then in the case of robotaxi, this factor disappears completely. As a result, the cost of a ride could become significantly lower than existing services. Some experts even predict that the price of a ride in an autonomous taxi could eventually become comparable to the cost of public transportation in major cities. If such a scenario actually becomes reality, the consequences would be enormous. Essentially, it could lead to the largest transformation of the transportation industry in the past 100 years. The taxi market would change, the car-sharing market would change, the personal vehicle market would change, urban infrastructure would change, the very logic of how people move around would change. Imagine a future metropolis. Huge parking lots gradually disappear. Cars no longer remain unused for 23 hours a day. Instead, They operate continuously, transporting passengers. The efficiency of transportation usage increases several times over. Traffic congestion decreases. The need to build new parking facilities decreases. Vast areas within cities are freed up. That is why many economists view robotaxi not simply as a new vehicle, but as a platform capable of changing the structure of the modern urban economy. However, along with enormous opportunities come enormous risks. The main challenge remains regulators. Even if Tesla proves the absolute safety of its system tomorrow, the company will still have to go through an incredibly complex process of approvals with government authorities in different countries. Every accident involving an autonomous vehicle immediately attracts the attention of global media. Every algorithm error becomes a subject of discussion among politicians, experts, and regulatory agencies. That is why many specialists believe that technological readiness may arrive significantly earlier than the legal readiness of governments to allow mass deployment. Today, this factor is considered one of the biggest obstacles on the path toward a full-scale robotaxi launch. Tesla must not only create a functioning artificial intelligence system, the company must convince authorities that this system is safer than a human driver. This is where the most interesting part of the story begins, because statistics show an unusual trend. With every new software update, autonomous driving performance indicators continue to gradually improve. Millions of kilometers of data are collected by Tesla vehicles every day, allowing neural networks to learn almost in real time. Essentially, the company is building the world's largest collective learning system for vehicles. Every Tesla becomes a source of information for the entire network. Every intersection, every traffic light, every road situation, all of this is transformed into data for training artificial intelligence. If Musk's strategy proves successful, the world may witness the emergence of the first truly global autonomous transportation platform in human history. As Tesla moves closer to launching robotaxi, more and more attention is being drawn to the expected technical specifications of the future platform. Although the company traditionally keeps many details secret until an official presentation, Wall Street analysts, automotive experts, and insiders are already trying to create the most accurate possible picture of what Tesla's first mass-market autonomous transportation system will look like. One of the key advantages of the future robotaxi is expected to be its range. According to estimates from several analytical agencies, including specialists tracking the development of Tesla's battery technologies, the autonomous taxi will need to operate almost around the clock. This requires not only high energy efficiency, but also an extremely fast charging infrastructure. That is why many experts connect the launch of robotaxi with the further expansion of the supercharger network, which is already considered one of the most advanced charging networks in the world. According to several industry specialists, the range of future autonomous taxis could exceed 500 kilometers on a single charge. Some analysts believe that new generations of batteries may allow vehicles to approach the 700-kilometer mark, depending on configuration and operating conditions. For an ordinary user, this may simply seem like an impressive number, but for the robotaxi business model, it has a completely different meaning. The longer a vehicle can operate without charging, the more passengers it can transport per day, and the higher its economic efficiency becomes. This economic factor is Tesla's main argument. If we look at modern taxi services, it becomes clear that a significant portion of the ride cost is connected to paying the driver. When this factor disappears, the entire financial model begins to look completely different. Many investment funds are already building forecasts suggesting that one autonomous Tesla vehicle could generate significantly more revenue for its owner than a traditional personal car throughout its entire operational life. One of the most interesting scenarios is the one Elon Musk has repeatedly mentioned in his presentations. According to this concept, Tesla owners will be able to connect their vehicles to the robotaxi network during the periods when they are not using them. While a person is at home, at work, or on vacation, their car could perform rides for other passengers and generate income. Essentially, the vehicle becomes not just a means of transportation, but a full-fledged asset. Imagine that one morning you wake up, walk up to a mirror, and realize that for the first time in the history of humanity, death no longer feels inevitable. No, this is not about a magic pill, not about a fictional elixir of youth, and not even about some secret project that will supposedly change the world tomorrow. This is about an idea that until very recently seemed like pure science fiction, but today is increasingly being discussed in the laboratories of the world's largest technology companies. The idea of digitizing human consciousness. Imagine that one day a person's memory, character, recollections, emotions, habits, knowledge, and even personality itself could exist not only inside a biological brain, but also in digital form. If such a thing ever becomes possible, it will not be just another technological breakthrough. It will become the most monumental event in the entire history of civilization. Perhaps at that moment, humanity will divide its history into two eras, before digital immortality and after it. But the most interesting part is that if you ask most people today, which company could potentially bring humanity closer to such a technology, many will surprisingly not name Google or OpenAI. Instead, one name is increasingly mentioned: Neuralink. Elon Musk's company, currently best known for its brain implants, is already taking its first steps toward connecting the human brain with a computer. And although Neuralink itself is not officially working on digital immortality, many experts believe that such technologies could become the first building block in a far more ambitious future. At first glance, it seems that there is a huge gap between controlling a computer cursor with thought and transferring human consciousness into a machine. But if we look closely at how modern neuroscience is developing, it becomes clear that both technologies start from the same task: learning to understand the language of the brain. After all, the human brain does not speak in words. It communicates through electrical impulses, chemical signals, and incredibly complex chains of interactions between billions of neurons. Every time you remember the face of a loved one, hear your favorite music, or make a decision, billions of microscopic processes occur simultaneously inside your head. These are exactly the processes that modern brain-computer interfaces are trying to learn to read. And here is where things become even more interesting. Many people imagine Neuralink as a device that simply allows you to move a computer cursor with your mind. But in reality, this achievement is only the tip of a massive iceberg. For a computer to understand the intention of a person to press a virtual button, it must first learn to recognize the activity of specific groups of neurons. This means that artificial intelligence is gradually beginning to learn the language of the human brain. Today, this language is only understood at the most basic level. A computer can detect the intention to move a cursor, select a letter, or perform a simple action. But what will happen in 10, 20, or 30 years? What if one day computers can understand not individual commands, but complex memories, emotions, or even entire thoughts? This is where we enter a domain where modern scientific achievements end and cautious scientific hypotheses begin. No company in the world today can read human consciousness as a whole. Moreover, scientists still cannot even define consciousness precisely. We know how individual neurons work. We understand how electrical signals are transmitted. We can build incredibly detailed maps of the brain. But we still cannot answer the main question. Why does this electrical activity give rise to the feeling of a self? Why does a human not simply process information, but experience themselves as a personality? This mystery remains one of the greatest scientific enigmas of the 21st century. And yet the pace of progress in recent years is astonishing. Not long ago, scientists could observe only small regions of the brain. Today, thanks to artificial intelligence and modern electron microscopes, researchers are already creating three-dimensional maps of millions of neural connections. Companies and scientific institutions are gradually getting closer to understanding the architecture of the human brain. The more such maps appear, the better researchers understand how different regions of the brain interact with each other. Now imagine that such research continues not for 10 or 20 years, but for an entire century. Artificial intelligence becomes significantly smarter than humans. Computing power increases thousands or even millions of times. Robots gain the ability to operate at the atomic level. Medical technologies make it possible to observe every neuron almost in real time. In such a world, the idea of full digital brain modeling no longer looks absolutely impossible. That is why many experts closely follow Elon Musk's statements. Musk has repeatedly said that the long-term goal of Neuralink is to create the closest possible connection between humans and artificial intelligence. In his view, if a super-intelligent AI ever appears, humans will need a way to interact with it much faster than is possible today through a keyboard or a smartphone screen. Neuralink is seen as a kind of digital bridge between the human brain and future computing systems. At the same time, Musk has not stated that the company is already working on mind uploading or digital immortality. This is important to understand. However, many researchers believe that the development of brain-computer interfaces could potentially bring science closer to answers to questions that today seem purely fantastical. But why does the idea of digital immortality generate such interest in the first place? The answer is quite simple. Throughout human history, people have tried to defeat death. Some searched for the philosopher's stone, others dreamed of an elixir of eternal youth. Modern medicine extends life, treats diseases, and performs organ transplants. However, all these methods have limits. The biological body ages. Cells gradually lose their ability to regenerate. And if it ever turns out that personality can be preserved independently of the body, the consequences would be so vast that they would transform literally every sphere of human life. Imagine a doctor with 500 years of experience. Imagine an engineer designing spacecraft using knowledge accumulated over several centuries. Imagine a scientist who does not lose their discoveries with their own life. If a human personality could truly exist in digital form, civilization would begin to develop at a completely different pace. Each generation would no longer start almost from scratch. Knowledge could be transmitted not only through books, universities, and video lectures, but perhaps one day even directly through interaction between the brain and computing systems. For now, this remains a scientific hypothesis, but such ideas are increasingly discussed in academic circles. However, this raises a question that concerns philosophers no less than engineers. If one day it becomes possible to create an exact digital copy of your brain, would that truly be you? Or would it simply be a digital double that believes it is you, remembers your childhood, recognizes your friends, and sincerely believes that it is the continuation of your personality? Today, no one knows the answer, and perhaps this question will turn out to be much more complex than any engineering challenge. Therefore, the discussion about digital immortality is not only a discussion about technology, it is a discussion about the nature of the human being, consciousness, and life itself. If Neuralink continues to develop at this pace, it is quite possible that future generations of engineers, building on the achievements of this company and modern neuroscience as a whole, will come closer to answers that today seem almost unattainable. Perhaps right now, humanity is not witnessing the creation of digital immortality, but only the very first, barely noticeable step on an unimaginably long path toward it. But if we continue to think further, it becomes obvious that the very idea of digital immortality is not limited by computers at all. Many people assume that the main problem lies in insufficiently powerful processors or neural networks that are too slow. In reality, this is far from true. The most difficult task is understanding the human brain itself, and here Neuralink could potentially play a much more important role than it might seem at first glance. Today, the Neuralink implant is capable of reading only the activity of a small part of the brain. Thousands of ultra-thin electrodes register the electrical impulses of neurons, after which artificial intelligence begins to look for patterns. Imagine a person who has never heard a foreign language. At first, it will be just a chaotic set of sounds for them, but gradually they begin to understand individual words, then short sentences, then entire dialogues. In roughly the same way, the interaction between artificial intelligence and the human brain is developing today. For now, computers understand only the simplest commands, but each new generation of algorithms learns to recognize increasingly complex patterns. That is why many researchers believe that the next 20 years will become an era of a real revolution in neuroscience. In recent months, a trend has begun to emerge in the technology industry that at first glance looks like just another wave of automation, but on closer examination reveals a fundamental shift in the labor economy. And at the center of this shift is Tesla and its seemingly side project, the humanoid robot Optimus. At first, many viewed Optimus as a demonstration product. Impressive, but far from real commercial viability. However, the situation changed sharply after discussions began in closed circles about the integration of new artificial intelligence models, including developments related to XAI and its Grok system. According to sources familiar with internal testing, it is this combination, the robot's physical body and advanced AI, that may become the starting point for an entirely new class of assets. We are talking about robots as income-generating units. An idea that just a couple of years ago sounded like science fiction is now increasingly being discussed at the level of investment banks, venture funds, and major corporations. Elon Musk himself has repeatedly hinted at this direction, suggesting that in the future a person could purchase a robot that works in their place and effectively generates profit, covering its own cost. But what does this mean in practice? According to insiders, Tesla is already testing scenarios in which Optimus is capable of performing a wide range of tasks, from logistics and manufacturing work to service professions. In closed demonstrations, the robot already shows the ability to work as a barista, serve customers, perform courier functions, and even interact with passengers in the role of a driver or operator of autonomous transport. The key difference from previous generations of robots is that Optimus does not simply execute pre-programmed actions. Thanks to integration with advanced language models, it is capable of analyzing situations in real time, adapting to new conditions, and making decisions without constant human supervision. And this is what makes it potentially economically autonomous. According to analysts' estimates, if such a robot can work at least 12 to 16 hours per day, performing tasks in services or logistics, its potential annual income could range from $20,000 to $60,000 depending on region and type of work, with an estimated device cost in the range of $20,000 to $30,000. This means the robot could theoretically pay for itself within 1 to 2 years. And this is the point that attracts the greatest interest from investors. Essentially, a new class of assets is emerging. Not real estate, not stocks, but a physical object with artificial intelligence that generates cash flow. Some analysts already compare this to the emergence of rental housing in the last century, or the development of car-sharing and ride-sharing platforms in the 2000s. However, along with this potential, serious risks also arise. First, there is the issue of regulation. In most countries, legislation is simply not prepared for the idea that a worker may not be human. Who is responsible for a robot's actions? Who pays taxes on its income? Can a robot be officially registered as an economic participant? According to sources in European regulatory bodies, discussions on these questions have already begun, and some countries are considering introducing special licenses for the commercial use of humanoid robots. In the United States, according to think tanks close to Congress, working groups are also being formed to study the legal consequences of mass deployment of such systems. The second risk is social pressure. If robots truly become capable of performing a significant share of service sector work, this will inevitably lead to job displacement. Even now, trade unions in some countries are expressing concern, stating that such technologies could accelerate the process of human replacement in the economy. And this is not just a theoretical threat. Scenarios modeled by analysts suggest that with the mass deployment of humanoid robots, up to 30% of jobs in the service sector could be at risk within the next 10 to 15 years. This particularly concerns professions such as couriers, cashiers, baristas, warehouse workers, and drivers. But there is also an opposing view. Some experts believe that the emergence of such technologies will create new markets and new jobs in robot maintenance, software development, system monitoring, and control. Moreover, they argue that this could lead to higher overall economic productivity and, as a result, an increase in living standards. The third key factor is competition. Despite Tesla currently being at the center of attention, Other major players are also actively working in this direction. Companies from China, Japan, and South Korea are already presenting their own humanoid robot prototypes, while technology giants are investing billions of dollars into AI and robotics development. According to insiders, China is already considering the possibility of mass-producing robots for the domestic market in order to support industry and reduce dependence on human labor. In Japan, traditionally strong positions in robotics may give the country an advantage in service robots. This means that in the coming years, a real humanoid race may begin. And in this race, the key factor will not only be hardware, but also intelligence. That is why integration of advanced AI systems such as Grok is considered a critical advantage. A robot without intelligence is just a machine. A robot with AI is a full participant in the economy. But how realistic are these scenarios? According to analysts' estimates, the first commercially viable models capable of performing a wide range of tasks could appear within 3 to 5 years. However, mass adoption, where robots become accessible to ordinary users, will likely take 7 to 10 years. This is the time horizon currently being discussed in investment circles. Some venture funds are already beginning to build portfolios focused on a robotized economy, including not only device manufacturers, but also companies creating infrastructure, from charging stations to cloud-based management platforms. Interestingly, entirely new business models are already emerging in this context. For example, robot as a service, where a user does not buy the device but rents it, receiving a share of its income, or shared ownership models, where several investors purchase a robot and split the profits from its operation. This effectively turns robots into financial instruments. However, the main question remains trust. Are people ready to entrust a robot not only with physical labor, but also with customer interaction? Are companies ready to integrate such systems into their workflows? And are governments ready to allow it? The answer is not yet clear, but one thing can be said with certainty. If even part of these scenarios becomes reality, we will be standing on the threshold of a new economic era, where the boundary between humans and machines in the context of labor will gradually begin to fade. And perhaps, for the first time in history, a situation will emerge where work is no longer a mandatory condition for income, because the work will no longer be done by a human, but by their robot. But the story does not end there. According to information from several sources close to major technology funds in Silicon Valley, interest in what is being called the second layer of the robotic economy has surged in recent months. If the first layer is when a robot simply performs work instead of a human, then the second layer is when robots begin interacting with each other, forming fully autonomous chains of production and services. Imagine a situation. One robot works in a coffee shop, another handles logistics, a third manages a warehouse, a fourth repairs equipment, and all of them are connected by a single AI-based control system. In this system, the human is no longer a participant in the process, but its owner. This scenario is now being actively discussed in analytical reports from publications such as Bloomberg and Financial Times, where the idea is increasingly raised that within the next 10 to 15 years, a parallel economy may emerge in which a significant share of work is performed by machines. Insiders claim that Tesla is already considering the possibility of creating its own platform for managing such robots, a kind of app store for labor, where owners could assign their Optimus robots to different tasks and receive payments automatically. In effect, this is the creation of a market where work becomes a digital service. And here, another extremely important point emerges: scale. If today we are talking about thousands or tens of thousands of robots, then in the case of successful commercialization, the number could grow to millions of devices. Some analysts suggest that within 15 to 20 years, the number of humanoid robots in the world could exceed the number of people employed in the service sector. And this is no longer just a technological trend. It is a structural transformation of the entire global economy. In the history of humanity, there are technologies capable of changing the world so dramatically that after their appearance, civilization literally begins to live by new rules. Once, such a technology was the wheel, then the steam engine. Later came electricity, aviation, the internet, and rockets that allowed humans to leave the boundaries of Earth for the first time. But there is one idea that for more than a century has been considered perhaps the most revolutionary concept in the entire history of space exploration. Many leading engineers call it a true dream of humanity. Others describe it as the most insane engineering project ever seriously discussed. And some scientists believe that if such a structure is ever actually created, that day will mark the beginning of a new era in space. Today, we are talking about the space elevator. At first glance, the very idea sounds so futuristic that most people assume it belongs purely to science fiction. Imagine a gigantic structure extending far beyond Earth's atmosphere, but it is not actually a tower. It is an incredibly thin, yet ultra-strong cable, almost 100,000 kilometers long, connecting the surface of our planet with space. Instead of rockets, special electric cabins would move up and down along this giant cable, like ordinary elevators inside a skyscraper, except that instead of reaching the 50th floor, they would be capable of carrying a person directly into Earth orbit, without a deafening launch, without hundreds of tons of burning fuel, without extreme overloads, and without expensive rocket launches. Until recently, such an idea seemed impossible, but today it is discussed not only by science fiction writers, but also by some of the world's largest engineering companies, space agencies, and scientists working on the materials of the future. That is why in recent years, interest in the space elevator has begun to grow rapidly again. New studies focused on ultra-strong materials, orbital infrastructure, and the possibilities of building such structures are appearing more frequently in scientific publications. Many specialists believe that if humanity truly plans to build cities on the moon, extract valuable resources from asteroids, and eventually transform Mars into a second planet for human life, then achieving this without a fundamentally new method of delivering cargo into space will be extremely difficult. And the space elevator looks like one of the boldest ideas capable of changing literally everything. But what exactly is such an elevator? How would it work? Why can't it be built today? Who is actually researching such technologies? Why have the world's largest space agencies not completely abandoned this idea? What has Elon Musk said about it? Could SpaceX build such a structure before anyone else? And could humanity really one day stop relying on the launch of most rockets? This is exactly what we will discuss in detail today. The most surprising thing is that the idea of a space elevator did not appear in the 21st century. The concept was first proposed by Russian scientist Konstantin Tsiolkovsky at the end of the 19th century. Inspired by the construction of the Eiffel Tower, he imagined a gigantic structure extending far into space. Later, engineers realized that building a tower of such height was impossible, but the idea of connecting Earth with orbit remained alive. Over time, scientists proposed a completely different approach, using not a tower, but an ultra-strong cable held in place by the centrifugal force of Earth's rotation. This concept is now considered the classic space elevator design. If we imagine Earth from space, we can picture a massive cable attached exactly at the equator. The upper part of the cable passes beyond geostationary orbit and continues for tens of thousands of kilometers, where a massive counterweight is located. Due to the rotation of our planet, this counterweight constantly keeps the cable stretched, maintaining it in a stable position. Special electric climbers then begin moving along it, receiving energy either through the cable itself or through lasers transmitting power over a distance. Gradually, such cabins would lift equipment, satellites, construction materials, and even people directly into space. The most incredible thing is that such a system would require almost no use of enormous amounts of rocket fuel. Today, one of the main reasons space launches are so expensive is precisely the need to accelerate a multi-ton rocket to orbital velocity. Every ton of payload requires massive fuel reserves. Even the most advanced reusable rockets remain extremely complex engineering systems. A space elevator could potentially change this entire economic model. Imagine that instead of launching hundreds of rockets every day, ordinary cargo trains arrive at the base of the elevator. Containers are loaded into cabins, which then slowly begin moving upward. After several days, they are already in orbit. the cost of delivering each kilogram of cargo could decrease by dozens of times. Some studies suggest that in the distant future, it could fall from thousands of dollars per kilogram to just a few dozen dollars. For the space industry, this would represent a true revolution. That is why many engineers compare the space elevator to the emergence of railways in the 19th century. While people transported goods only by horses, the economy grew slowly. But once railways appeared, industry began developing at a completely different pace. A similar transformation may await space. Instead of individual launches, humanity could organize an almost continuous flow of cargo between Earth and orbit. However, this is where the most difficult part of the entire story begins. The main problem of the space elevator is not money, and it is not even the enormous size of the structure. The main problem is the material of the cable itself. Today, there is no material that is both light enough and strong enough to withstand the required tensile forces. Ordinary steel would break under its own weight after only a few dozen kilometers. Titanium is also unsuitable. Kevlar, used in body armor, is too weak. Even the most advanced composite materials available today still fall far short of the required properties. For decades, the main hope of scientists has been carbon nanotubes. Their theoretical strength really could allow the creation of the necessary cable. However, the problem is that humanity can currently produce only very small structures from these materials. A space elevator would require an almost perfect cable tens of thousands of kilometers long without a single critical defect. At the moment, such technologies remain far beyond modern manufacturing capabilities. In addition to strength, there are dozens of other challenges. The cable would constantly be exposed to micrometeorites, space debris, temperature fluctuations, solar radiation, and electrical discharges in the atmosphere. Any serious damage could lead to catastrophic consequences. Therefore, engineers would need to develop a complex system of automatic monitoring, continuous repair, and structural redundancy. Another extremely difficult issue remains the choice of construction location. The elevator's base would need to be located almost exactly on the equator. Ideally, it would also be positioned over the ocean to reduce risks to densely populated areas. But this creates a question of international law. Who would own such an object? Which country would be responsible for safety? Who would be allowed to use the elevator? How would maintenance costs be distributed? What would happen in the event of conflict between nations? All of these questions still remain without final answers. The cost of such a project is also the subject of major debate. Some studies estimate construction costs at tens of billions of dollars. Others believe the real cost could exceed several hundred billion. Some analysts even suggest that the full development cycle, including advanced materials, infrastructure, the orbital counterweight, and the ground station, could approach $1 trillion. At the same time, the final cost will depend not only on engineering solutions, but also on the price of new materials, energy systems, and automated manufacturing. Despite this, interest in the idea has not disappeared. One of the most famous companies that has openly discussed the possibility of building a space elevator remains the Japanese Obayashi Corporation. Company representatives have published concepts suggesting that if the necessary materials become available, such a project could one day become a reality. Japanese research groups have also conducted small experiments with miniature space elevator models between satellites, testing individual engineering principles. Research is also being carried out at various universities and within separate NASA scientific programs. However, specialists emphasize an important detail. This is not yet about the beginning of construction, but about fundamental research into materials, cable dynamics, and possible architectures of future systems. In recent months, processes have begun unfolding inside the electric vehicle industry that may appear unnoticed by the general public, but behind the scenes, they are already causing serious tension among the world's largest technology companies. According to several analytical agencies, including Bloomberg Intelligence and Morgan Stanley Research, Tesla's team under Elon Musk is conducting a confidential development program focused on a new generation of battery technologies that could radically transform not only the electric vehicle market itself, but also the entire global energy infrastructure. This is not simply about improving existing batteries, but about attempting to take the next evolutionary step. A step that could finally eliminate the main barrier preventing humanity's mass transition to electricity. Among the many projects being discussed by insiders, one name is appearing more and more frequently: Tesla Cryocell. According to sources close to Tesla's component suppliers in Asia, this is an internal development code associated with a fundamentally new approach to thermal management inside battery cells. Although the company itself has not officially confirmed the existence of such a project, indirect signs suggest that Tesla's laboratories are indeed working on technology that goes far beyond the traditional understanding of batteries. To understand why cryocell could become a true revolution, it is necessary to understand the main problem facing modern batteries. Any battery is a compromise between capacity, power output, charging speed, and lifespan. But the key limitation remains heat. During fast charging and high loads, batteries heat up, chemical processes accelerate, the internal structure degrades, and this is precisely what limits the development of the entire industry. Essentially, today's electric vehicle is not only a question of energy, but also a question of temperature control. This is where, according to insiders, the story of cryocell begins. Unlike traditional cooling systems that use liquid to remove heat, the new concept reportedly involves active management of the thermal state of each individual cell at a microscopic level. Sources claim that Tesla is experimenting with materials capable of instantly absorbing and redistributing heat, creating what is described as a quasi-cryogenic stabilization effect. This does not mean the battery is cooled to extremely low temperatures like in scientific laboratories, but rather that local overheating, which is one of the main causes of degradation, can be dramatically reduced. Moreover, according to information appearing in Goldman Sachs analyst reports, Tesla is actively investing in research into phase-change materials inside batteries. These are substances that can change their state while absorbing large amounts of energy without increasing temperature. In theory, this allows the battery to operate in a mode where heat does not accumulate, but is constantly redistributed and partially returned to the system. This very effect has led to the emergence of a term now actively discussed in technology circles: regenerative cooling. If these developments truly reach the stage of a commercial product, the consequences could be enormous. First, charging speed. Today, even the most advanced electric vehicles are limited by thermal constraints, but cryocell could potentially allow a battery to charge from 10% to 80% in just a few minutes without the risk of damage. This would effectively remove the main advantage of gasoline-powered vehicles: refueling speed. Second, battery lifespan. According to insiders, one of the project's goals is to create a battery capable of withstanding hundreds of thousands of charging cycles without significant degradation. This means that a vehicle could operate for decades without replacing the battery, while the battery itself could later be reused in energy storage systems. The third factor is power output. Cryocell could open access to entirely new levels of energy delivery, allowing electric vehicles to achieve performance characteristics that today seem impossible. Acceleration, stable operation at high speeds, and the absence of overheating even under extreme loads. All of this becomes possible with effective temperature management. But perhaps the most important aspect is that Tesla is not viewing cryocell solely as an automotive technology. According to the Financial Times, the company is increasingly moving toward becoming a global energy player, and new batteries could become the foundation for large-scale energy storage systems. This means cryocell could potentially be used in power grids, homes, factories, and even at the level of entire cities. However, the path to such a technology will not be simple. The main challenge is cost. Phase-change materials, complex thermal management systems, and new cell architectures all require enormous investments and significant time to scale. In addition, there is the question of reliability. Any new technology must undergo years of testing before it can be safely introduced into mass-market products. This is why most analysts agree that if cryocell truly exists, its market appearance is unlikely before the end of the decade. But even the fact that such development is reportedly underway is already affecting the industry. Tesla's competitors, including Chinese giants and traditional automakers, are accelerating their own research programs, realizing that the next breakthrough could completely change the balance of power. For Tesla itself, the launch of such a technology could become the moment that finally solidifies its leadership. If the company becomes the first to offer a battery that eliminates the main weaknesses of current solutions, it could create an effect comparable to the release of the iPhone in the mobile device world. The market could literally restart, and those who fail to adapt may be left behind. But there is another scenario that experts are increasingly discussing. If cryocell proves too complex or too expensive for mass production, Tesla could initially use the technology in premium products or energy solutions, gradually reducing costs and expanding the scale of application. This approach has already been used by the company before and has proven effective. In any case, even if some of the information about cryocell turns out to be exaggerated, the overall logic of technological development suggests that the industry is indeed approaching major changes. Limitations that until recently seemed fundamental are gradually beginning to disappear, and companies like Tesla are at the center of this transformation. And if even part of what insiders are currently discussing turns out to be true, the coming years could become a period when batteries stop being the weak link and become the main driver of technological progress. And that would change not only automobiles, but the entire structure of modern civilization. This is why the project known as Tesla Cryocell is already being viewed not simply as another development, but as a potential turning point, after which the world of electric energy could become completely different. But the story does not end there. As information about the potential cryocell technology begins to leak into the professional community, it is not only the perception of Tesla as an automaker that is changing, the entire logic behind evaluating its future is changing. Previously, the company was compared with traditional automotive brands, later with technology giants. But now an increasingly common view is that Tesla could become something much larger, a new type of infrastructure company controlling one of the key resources of the 21st century, energy. And this raises one of the most debated questions. What will happen to the market if Tesla really gains a technological advantage of this scale? According to analysts at ARK Invest, even a small lead in battery efficiency could create an exponential effect, because batteries are the foundation not only of transportation, but also of the entire digital economy. Data centers, artificial intelligence, autonomous systems, all of these require stable and affordable energy storage. In this context, cryocell stops being just a battery for a vehicle. It becomes the foundation of a new energy architecture. In recent months, information has begun emerging around one of the most ambitious space companies in the world that could radically change humanity's understanding of interplanetary travel. According to several sources, including industry publications, analytical centers, and leaks from engineering circles, SpaceX is indeed working on a fundamentally new engine technology that could reduce the flight time to Mars from the usual 6 to 9 months to just a few weeks. And although the company officially continues to focus on its massive Starship system and Raptor chemical engines, insiders claim that behind the scenes a much more radical solution is being developed, a next-generation fusion engine, unofficially known as aerofusion. The core idea behind this technology is the use of controlled nuclear fusion not to generate electricity, as is currently being explored in the energy sector, but directly to create thrust. This means that instead of burning fuel, as modern rockets do, the engine uses the enormous energy released during the fusion of light atomic nuclei. In theory, such a system could generate thrust orders of magnitude greater than any existing solution, while providing an incredibly high specific impulse. This parameter is one of the most important factors in space travel because it determines how efficiently an engine uses fuel. According to information appearing in several technology publications, aerofusion represents a hybrid between a compact fusion reactor and a plasma accelerator. At the center of the system is a reaction chamber where conditions similar to those found inside stars are created. Temperatures reach tens of millions of degrees, and maintaining plasma in such conditions is only possible with the help of extremely powerful magnetic fields. That is why the reactor is surrounded by a complex system of superconducting magnetic rings that create what is known as a magnetic confinement system. The plasma does not touch the walls of the chamber, but remains suspended, which prevents the destruction of the structure. Then, the most interesting part begins. Unlike traditional fusion systems, where the energy from the reaction is converted into heat and then into electricity, aerofusion uses direct conversion of energy into thrust. Charged plasma particles are directed into a nozzle using magnetic fields and accelerated to enormous speeds, creating propulsion. Essentially, this is not just an engine, but a controlled stream of energy transformed into motion. If the calculations discussed in closed engineering circles are accurate, such an engine could provide enough acceleration for a spacecraft to not simply accelerate and then coast toward Mars as current missions do, but to continuously accelerate for a significant portion of the journey and then actively slow down in the same way. This is what would reduce travel time to just a few weeks. Some estimates even suggest the possibility of reaching Mars in around 14 to 20 days, something that until recently was considered completely impossible. However, behind these numbers lies a huge range of technical challenges that have still not been solved. The biggest one is the stability of the fusion reaction. On Earth, scientists have spent decades trying to achieve sustainable and controlled fusion, and only in recent years have the first major breakthroughs appeared in this field. Moving such technology into space, making it compact, reliable, and safe, is a task that requires fundamentally new solutions. Another challenge is cooling. Even though plasma does not come into contact with the reactor walls, the system itself experiences enormous thermal loads. In the vacuum of space, removing heat becomes a separate engineering challenge. According to rumors, the solution may involve massive radiators that would unfold in space and release heat through radiation. Radiation is another critical issue. Fusion reactions produce streams of high-energy particles that could pose a danger to a crew. This means that the spacecraft would need to be equipped with a complex protection system, including shielding and possibly the use of magnetic fields to deflect charged particles. Interestingly, some sources claim that SpaceX is considering integrating aerofusion into future versions of Starship, or even developing an entirely new class of spacecraft specifically designed for this type of engine. Such vehicles could become the first true interplanetary transport systems, capable of performing regular flights between Earth and Mars. In terms of cost, in the early stages it would be enormous. The development, testing, and certification of such an engine could cost tens, if not hundreds, of billions of dollars. However, in the long term, the technology could radically reduce the cost of interplanetary travel. Faster missions would mean lower life support expenses for the crew, reduced risks, and the possibility of more frequent missions. The main revolution of aerofusion is not only speed, it is about a complete transformation of the logic of space travel. Today, a mission to Mars is a rare event requiring extensive preparation and massive resources. With such engines, interplanetary flights could become routine. This opens the way to permanent colonies, the development of an interplanetary economy, and possibly an entirely new industry. According to analysts, if SpaceX truly manages to realize such a technology, it would be a moment comparable to the introduction of the first jet aircraft on Earth. It would mark a transition from an era of slow, expensive, and risky flights to an era of fast and relatively accessible travel. Nevertheless, it is important to understand that at present, aerofusion remains a concept, albeit a highly promising one. There is no official confirmation of such an engine being developed, and all leaks and insider information should be treated with a degree of skepticism. But the very fact that such ideas are being discussed at the level of leading engineers and companies suggests that humanity is indeed standing on the threshold of a new era in space exploration. And even if the first version of such an engine does not appear tomorrow, but in 10 or 20 years, it would still mean that the path to the stars has become significantly shorter. Perhaps it is precisely such technologies that will ultimately turn Mars from a distant and unreachable goal into the next step in the evolution of human civilization. However, As information about the Aerofusion project begins to leak into the public domain, an increasing number of experts are focusing on one extremely important aspect. If this technology is indeed at least at the prototype stage, it would mean that a fundamental shift has already occurred within SpaceX in how future transportation is being understood. This is not just about a new engine, but about a transition from the chemical era of spaceflight to an energy-based era. And this distinction is fundamental. Chemical engines are limited by the energy of chemical bonds, whereas nuclear fusion operates with energy that is orders of magnitude higher. It is the difference between a campfire and a small sun contained within an engineered structure. According to sources close to the aerospace industry, in recent years, SpaceX has been actively building expertise not only in rocketry, but also in adjacent fields: materials science, cryogenic systems, plasma control, and high-temperature electronics. These seemingly separate areas are in fact key components of a future fusion engine. This is why some analysts believe that preparation for such a breakthrough may have been underway for much longer than it appears, simply hidden under the cover of other projects. Of particular interest is the possible architecture of a spacecraft equipped with aerofusion. Unlike modern rockets, where the engine is just one part of the system, here it becomes the central element of the entire structure. In effect, the entire spacecraft is built around the reactor. Living modules, cargo sections, and control systems are placed at a maximum distance from the radiation source, connected by a long structural truss. This not only reduces radiation exposure for the crew, but also allows for optimized mass distribution. In addition, such a spacecraft, according to preliminary concepts, would be capable of continuous maneuvering in space. This means that flight trajectories would no longer be strictly tied to launch windows, as is currently the case. Missions to Mars could be carried out almost at any time, which fundamentally changes the entire logistics of interplanetary travel. It appears that this has actually happened. After a series of closed but extremely successful tests of a new version of the autopilot system, adapted specifically for Tesla semi-heavy trucks, the company has effectively reached the point that just a few years ago was discussed only as a distant possibility. According to several insiders from Silicon Valley, as well as sources close to Tesla's logistics partners, in the coming months, the company may begin real-world road tests of fully autonomous trucks across the United States. And if this information is confirmed, it will become one of the largest technological shifts in the transportation industry in recent decades. This is not simply an upgrade of the existing autopilot system. According to information that has leaked through industry publications and analytical reports, Tesla is developing a separate FSD architecture optimized specifically for freight transportation. And this makes sense, because the behavior of a multi-ton truck on a highway is radically different from that of a passenger vehicle. Moreover, sources claim that Tesla used the experience gained from launching autonomous taxi and robotaxi services to accelerate the development of Semi. That is why inside the company, this project is already unofficially being called the next phase of the autonomous revolution. But the most interesting part is the appearance and concept of the new version. According to people familiar with the early prototypes, the autonomous version of Tesla Semi may receive a unique visual style inspired by the company's latest autonomous transport concepts. We are talking about the so-called golden design, a smooth, minimalist body with lighting accents, emphasizing that this is not just a truck, but a fully autonomous system. This approach has already been tested on experimental robotaxi prototypes, and now it appears to be moving into the freight segment as well. Why is this so important? Because freight transportation is the foundation of the global economy. Almost everything you see around you, from food products to electronics, spends at least part of its journey on trucks. And this is where the main potential of the revolution lies. An autonomous Tesla Semi could operate almost continuously, without the human factor, without fatigue, and without mistakes caused by driver attention issues. This means lower logistics costs, faster deliveries, and a dramatic increase in the efficiency of the entire supply chain. Now imagine the scale. If such trucks begin to appear on roads in large numbers, this could change not only the transportation industry, but the economy as a whole. Companies would be able to reduce expenses, accelerate the movement of goods, and therefore either lower prices or increase profits. Warehouse logistics would become more predictable, and deliveries would become faster. Already today, analysts at major investment funds are discussing scenarios in which the adoption of autonomous trucks could transform the structure of global supply chains. However, this breakthrough also comes with serious challenges. First of all, there is regulation. Unlike passenger vehicles, trucks are subject to much stricter government oversight. Allowing multi-ton autonomous machines onto public roads requires not only technological readiness, but also political approval. According to sources, Tesla is already actively working with regulators in California and Texas to obtain permissions for the first tests. Secondly, there is the issue of safety. Yes, the FSD system is developing rapidly, but errors still occur. And while the consequences in a passenger car may be limited, in the case of a truck, the risks increase dramatically. That is why Tesla, according to reports, is conducting a huge number of closed tests at specialized facilities, simulating the most complex road scenarios. And here another important factor appears: competition. Tesla is far from the only company working in this direction. Companies such as Aurora, Waymo, and several Chinese companies are already testing autonomous trucks on selected routes. But Tesla has one key advantage: the scale of its data. Millions of vehicles around the world are already collecting data that is used to train neural networks, and this gives the company a massive advantage. What does Elon Musk himself say? In his recent statements, he has repeatedly hinted that autonomous freight transportation is one of the company's main priorities. According to him, this is where the multi-trillion-dollar market lies, a market Tesla intends to capture in the coming years. At the same time, Musk traditionally avoids giving exact timelines, but emphasizes that progress in the field of AI is moving faster than many people expect. When can we expect a full-scale launch? If we believe the current leaks and analytical forecasts, the first limited routes could appear within the next 1 to 2 years. These would be controlled corridors between logistics centers, where conditions are as predictable as possible. A full-scale mass deployment, according to experts, could take several more years, potentially closer to the end of the decade. And this is where we reach the most important question: what happens next? Because the introduction of autonomous trucks will inevitably lead to a transformation of the labor market. Millions of drivers around the world may face the need to change professions. This will create serious social and economic consequences, for which society is not yet fully prepared. But at the same time, new opportunities will emerge. New professions will appear related to managing autonomous systems, maintenance, programming, and controlling logistics networks. And in the long term, this could lead to the creation of a more efficient and sustainable economy. That is why many experts describe what is happening not simply as a technological upgrade, but as a true new generation industrial revolution. A revolution in which machines take over one of the most complex and critical tasks: moving goods around the world. And if the current signals turn out to be accurate, then we are approaching a moment that, in a few years, may be studied in textbooks as the beginning of a new era of transportation. An era where trucks no longer need drivers, and roads become part of a global autonomous system controlled by artificial intelligence. And perhaps this moment is closer than it seems. If we look deeper, it becomes clear that this is not just about a new technology, but about a fundamental shift in the logic of the entire transportation system. Because for the first time in history, we are approaching a moment when the movement of goods stops depending on humans as an essential element. This means that all the infrastructure that has been built around drivers for decades, rest schedules, driving time limits, the human factor, will gradually lose its importance. And this is where the most interesting part begins. According to information being discussed inside major logistics companies, Tesla may introduce not just a truck, but a complete transportation ecosystem. The idea is a network where every Tesla Semi is connected to a unified management system that optimizes routes in real time, takes into account traffic, weather conditions, warehouse capacity, and even changes in demand for goods. Essentially, this transforms transportation into a living, self-learning system where every element interacts with the others. Some insiders claim that Tesla is already testing algorithms capable of coordinating entire groups of trucks, so-called platoons. In this mode, several Tesla semi-trucks move synchronously at a minimal distance from each other, reducing air resistance and saving energy. At the same time, the entire convoy is managed centrally, and each truck acts as part of a single organism. This not only increases efficiency, but also opens the way to completely new transportation models. But even more radical is the idea of fully automated logistics chains. Imagine a scenario where a product is manufactured at a factory. A robotics system loads it into an autonomous Tesla Semi, which leaves without human involvement and heads to a warehouse where robots receive it, sort it, and send it further. In this chain, humans are either completely removed or perform only a supervisory role. And if such a model becomes widespread, it could fundamentally transform the structure of the global economy. At the same time, it is important to understand that Tesla is not operating in isolation. According to analysts, the largest retailers and logistics giants are already closely monitoring the development of this project. Some of them are reportedly participating in closed pilot programs, testing the integration of autonomous trucks into their supply chains. This means that demand for such solutions could appear almost instantly once the technology is considered reliable enough. The issue of cost also deserves special attention. At first glance, an autonomous truck may seem like an expensive solution, but when considering savings on driver salaries, reduced accident rates, optimized routes, and the ability to operate around the clock, such systems could become significantly more profitable than traditional ones in the long term. This is why many investment funds already view autonomous transportation as one of the most promising markets of the coming years.